Hi, this video, now we are going to talk about factoring polynomials. There will be several videos featuring this factorization, and this particular one will be concentrating on what we call the GCF. All right, again, GCF stands for greatest common factor, GCF, and group factorization. All right, let's begin. Number one is you can see the problem, and it's a three-term polynomial, and each term consists of two parts: coefficients, which are 4, -8, and 12, and I hope you can easily pick out the GCF will be 4 in that situation, and then the variable. The variable is y with literal exponents, right? And hope you remember that GCF, when you have this situation, is the one with the least or the smallest exponent. Here we are assuming that the n is a positive integer, so in that situation the yn will be the smallest. All right, so let's begin. Erase all this out. Okay, so this will equal to, I have an equal sign already. Okay, this will then equal to 4 is our GCF, and y to the n. Okay, so the question you need to ask yourself is that GCF times what will give you respective three terms. Okay, so first one should just be y, and I already pulled out y to the n, so what I need is one more n and plus 2. And you can check this by multiplying 4y to the n times y to n plus 2 will indeed give you this first term. All right, let's continue. So that's the first one, and then next one will be -2. And then y, and we have again 2n minus 1, so I need one more n and minus 1. All right, so again that exponent n minus 1 plus this n outside will give you the 2n minus 1. Just give you this plus this will give you this. All right, okay, let's continue, finish this off. So plus there'll be 3, and that would be it. There shouldn't be any other part besides a 3. All right, just erase. Oops, erase too much. Okay, all right, so that's the solution for the problem number 1. Okay, and the second problem, this one is a 4-term polynomial, and usually, not all the time, but usually the 4-term polynomial, you need to use this so-called group factorization. Okay, hope you remember group factorization. Here we group, or we pair them up and look out for one single GCF. So from the first pair, we know that GCF would be x to the n. Then we'll have so-called yn minus 1. Okay, from the second pair, the GCF will be 2, and we also have yn minus 1. Okay, and the sign is plus in between. Let me just write that out a little bit more clearly. So that is equal to xn yn minus 1 plus 2 yn minus 1. And anytime that you want to use GCF, these two parts must be identical. Okay, all right, then the final answer should be yn minus 1 times xn plus 2.